In this lesson, I'm going to cover similarity. So when we're talking about similarity, we have two different cases. So the first case is about triangles, while the second case is for any shape other than a triangle. So let's do the first case, which is about triangles. Now, if I have two triangles, one is a small triangle, while the second one is a big triangle. So I have triangle A, which is the smaller triangle, and triangle B, which is the bigger triangle. Now, two triangles are similar if corresponding angles are equal. That's it. So here I have to satisfy this condition only. So if corresponding angles are the same, then I can say that these two triangles, PQR and WXY, are similar. Now, if I tell you that this angle is 30 degrees, this angle is, let's say, 110 degrees, and this angle is 40 degrees. Now for triangle B, this angle is 30, this angle is 40, and this angle is 110 degrees. Now let's check if corresponding angles are equal. So this angle at P, which is 30 degrees, is equal to this angle at W. This angle at Q, which is 110, is equal to the angle X here, which is 110. And finally, the angle at R, which is 40 degrees, is equal to the angle at Y, which is 40. So I can say that corresponding angles are equal. Therefore, these two triangles are similar. Now, when I have two similar triangles, I can say that the length of the side PQ over the length of the corresponding side in triangle B, which is WX, is equal to the length of PR over the length of its corresponding side in triangle B, which is WY, which is equal to QR over XY. So I can say that PQ over the length of its corresponding side in the second triangle, triangle B, which is WX, this is equal to PR over the length of its corresponding side, which is WY, and this is equal to QR over the length of its corresponding side, which is XY. So that's only if these two triangles are similar. Now, the second case is when we have other shapes, such as rectangles, squares, whatever the shape is. So in this case, I have two rectangles. So I have rectangle A and rectangle B. So rectangle A is the bigger rectangle, while rectangle B is the smaller rectangle. Now, I can say that these two rectangles are similar if corresponding angles are equal and corresponding sides are in the same proportion. So here I have two conditions. The first is corresponding angles should be the same, and the second is that corresponding sides must be in the same proportion. Now we all know that all the interior angles of a rectangle are each 90 degrees. So this is 90, this is 90, this is 90, this is 90, and also in rectangle B, the angle here is 90, the angle at Y is 90, the angle at X is 90, and the angle at Z is 90. So corresponding angles are equal. Now to check if corresponding sides are in the same proportion, I need to do the following. So I want to check if the side QP over the length of its corresponding side in rectangle B, which is WX, is equal to QR over the length of its corresponding side in rectangle B, which is WY. Now, if these two fractions, QP over WX and QR over WY, are equal, then I can say that these two rectangles are similar. Now let's do this example, and it says find the side marked with the letter X. So I'm given two triangles. The first one is the smaller triangle, while the second one is the larger or bigger triangle. So first, let's check if these two triangles are similar. So when we are talking about triangles, the only condition that I should meet is that corresponding angles should be equal. Now this angle here is equal to this angle. And this angle is equal to that angle. And finally, this angle above is equal to this angle here. So corresponding angles are equal, therefore these two triangles are similar. Now to find X, I'm going to say that 5 over the length of its corresponding sides in the other triangle, which is 8, is equal to 2 over X. Now I need to cross multiply. So 5x is equal to 8 times 2, which is 16. So over 5 and here over 5. So x is equal to 16 over 5. So that's the value of x in the second triangle.